Have you ever wondered why some swimmers clock longer distances, while others seem to finish the race quicker? The answer lies in the concepts of position, distance, and displacement, key ideas in physics that help us understand motion. Welcome to Diara's Academy, where today we're diving deep into motion in one dimension, a topic that's not only essential for acing your exams like the SAT, JEE, NEET, or A-levels, but also a key to understanding how objects move in our everyday world. When we talk about motion in one dimension, we're focusing on movement along a straight line. Think of cars driving along a highway or swimmers moving in a lane. This type of motion is the simplest to analyze, and it helps us build a solid foundation for more complex topics in physics. Let's start with position. Imagine you're swimming in a straight lane in a pool. Your position is simply your location along that lane, measured from a chosen reference point, often called the origin. Think of a swimmer at the 50-meter mark in a 100-meter lane. That's their position. Now, let's talk about distance. This is the total path traveled, regardless of direction. If you swim 50 meters forward and then 50 meters back, the total distance you've covered is 100 meters, even though you may end up right where you started. Now comes the interesting part, displacement. Unlike distance, displacement is the shortest straight line between your starting point and where you end up. It's a vector, meaning it has both magnitude and direction. Let's say you start at the 0-meter mark in a swimming lane, swim 50 meters to the end, then swim 20 meters back. Your displacement isn't the total distance, it's simply 30 meters from where you started. Let's bring these ideas into real life. Think of two swimmers who starts at the 0-meter mark of a 50-meter swimming pool. 0-meter mark is the initial position of both the swimmers. Let's name them swimmer A and B. If swimmer A swims the entire length, his distance is 50 meters, and his displacement is 50 meters. Now if swimmer B swims 50 meters straight and swims back to the starting point, his distance is 100 meters, and his displacement is 0 meters. A simple example, but one that's critical for mastering physics exams. Now let's put this to the test with a quick problem you might see in exams. A swimmer swims 25 meters to the end of a pool, then 15 meters back. What is the total distance traveled and the displacement? The distance swimmer covers is 25 meters plus 15 meters, which equals 40 meters in total. The displacement, however, is 25 meters minus 15 meters, resulting in a displacement of 10 meters toward the end of the pool. Notice how distance measures the total path, while displacement measures the shortest straight line between the starting and ending points. Mastering this difference is key to acing physics problems. So to recap, position is your location along a path. Distance is the total path traveled. Displacement is the shortest path between your start and end points, with direction. Understanding these terms can give you the edge in exams and real-life applications alike. If this lesson helped clear up your doubts, be sure to like, subscribe, and hit the bell icon for more physics insights with Diara's Academy. We'll see you in the next video.